Hey folks, this is it. It's the last lesson of Honors Algebra 2. I'm really excited for this. It's the Law of Cosines. It's a really fun one too. This is it. This is it. This is it. This is the last. It's the last video. I mean, I make the intro videos after I make these, so it's not really the last video that I'm making, but it's the last one that you'll watch. Oh my gosh, what to say? Maybe I'll make like an end of year video. Should I do that? I feel like I should do that. Just saying good job, whatever. Maybe I'll do that. So maybe it won't be the last video, but maybe. It's the last lesson, right? But yeah, it's been real. It's been fun. Has it been real fun? I think it's been real fun. Honestly, I'm gonna miss you guys. Like I really liked this. Like I was there. How do I put this nicely? And I'll probably say this in the intro video as well. There are years where I would not have minded having the fourth 9 weeks off. I would have been like, okay, see you guys later. Peace out. Don't need to see you guys again. But I was having fun with you guys. I mean, like I thought it was like both my classes were like really all my classes, my freshman too. Like, it was having a good year. So it's a bummer. But I mean, I'll see you guys next year. You know, you're taking pre-calc across the hall. Like just instead of turning right into my class or going to Mr. Hooper's room, you're just gonna have Mr. D-Lab. So I'll be right down the hall. Who knows? Maybe I'll have one of you or some of you guys senior year for CCP Calc. You know, whatever. Okay, but yeah, but feel free to stop by and say hi. And, you know, whatever. If we're back in the fall, who knows? I mean, it's May 17th. I have no idea what's going on. Just think 2 months ago, March 17th, it was like right after, like when this all started. That's crazy. Okay, by now you probably all skipped ahead and like said, like, oh, geez, here's Laverick. Just talking. Okay, sorry. I know. I'm sorry. You never have to hear this again. Okay. Okay, here's law of cosines. Oh, get my face out of there. Okay, in the previous lesson, we talked about law of sines. Remember, law of sines, there was only unique cases where we could use law of sines, right? Let's think about the law of sines. Come on. Are you gonna obey me, pen? For law of sines, we only had a couple different things that we could do. We had angle, side angle, angle, side, which is just basically a variation of the two same things, like two angles and a side, whether it be included or not included. And then we had I'll spell it backwards, the bad word option, where we had to check both cases, and it got really, really intense, right? Law of cosines, a lot less intense. Why? Because the cosine function, the domain of the cosine function has like all of those options. So it's not like it's hiding any of the options that could exist in a triangle, where the sine restriction, was hiding all of these, second quadrant options that could have existed in a triangle. Cosine doesn't do that. So it's a little bit more straightforward. But here are the other options that you can use. Think about the only other options that we have: side angle side or side side side. If you got those, then you can use law of cosines. Pretty straightforward, right? Now, I like to derive the law of cosines in a little bit different way than the book does. Okay. Well, do I? Let me look at something. Do I? Yeah. Let me do this. Anyway, you know what? Even if it's different, even if it's not different, it's the same. I want to talk through it. I think it's fun. My version of fun, right? Last video, I might as well have some fun, right? Send to a different page. I did not look at this ahead of time, so I hope I don't butcher this. I don't wet the bed on this one. Oh, geez. Gosh, I hate when it gets distorted like that. Stop it. Don't get distorted. 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 Okay. So what the heck is going on in this diagram? Okay. Think about how we started the law of sines. We were just drawing any sort of triangle, ABC, labeling it with capital letters along the vertices, and then lowercase letters with the side across from that angle. So like this capital A, this is lowercase a, right? Now, just like we derived the law of sines, we're going to drop a height. Okay, we're going to drop a height. That's going to be our way to add in cosine there. Okay, now when I drop that height, however, it cuts side AC. It cuts side AC into two things. Okay. So what does it cut it into? Well, it cuts into, well, if this whole thing is B, we name this X, what would this be? B minus X, right? B minus X. The whole length B, take away X, whatever that is, right? Okay, so let's do Pythagorean on this right side. We would get A squared is equal to H squared plus B minus X squared. Right, so it gives A squared is equal to H squared. And now if we FOIL this, we're going to get B squared minus 2bx plus X squared. Right. It's late. I'm just going to check it. B minus X. So we got B squared minus bx plus X squared. Yeah, that's right. Okay. Now, where do I want to go with this? I gotta look back at what they're doing. Oh, duh, yeah. Duh, of course. Okay, I'm gonna combine here. So A squared is equal to, now I'm gonna rearrange. I'm gonna do this. I'm gonna say B squared minus 2bx plus H squared plus X squared. Now take a look here. Do you see X squared plus H squared anywhere? Ooh, we never used this left side of this triangle here. We know that X squared plus H squared is equal to, oh, look at that, C squared. So what I can say here is A squared is equal to B squared minus 2bx plus C squared. A little rearranging. A squared is equivalent to B squared plus C squared minus 2bx. Okay, I've got this X in here. X is no bueno, and I need to get rid of X, okay? So what I can do here is replace it with the cosine. Okay, think about this triangle in here. We know that the cosine is the adjacent over the hypotenuse, so we know that cosine of angle A is equivalent to X over C. Ooh. Little multiply by C action here. C times cosine A is going to be equal to X. So plug that in here. That gives me A squared is equal to B squared plus C squared. Looks a lot like Pythagorean, but not really. Minus 2 times B times C cosine A. And that, my friend, is the law of cosine. I didn't butcher it too much, just at the back of that one little thing. Right? Now, that's generalized. We dropped the height from B to D. We could have dropped the height from A to A, or B to D, B to side B. We could have dropped it from A to A, side A, or dropped it from angle C to side C, right? So we can generalize this formula to any of the sides. Now, here's the unique part, okay? Looking at the arrangement, I always remember it like this first one, right? And I know that I can apply A, B, and C to any of the three sides. But look at what I have here. The unique positioning is that side A, is across the equal sign, is across the equation from angle A. Just like angle A is across the triangle from side A. Okay, that's the unique arrangement. These B and C are just the other two sides. Okay, so what goes on the left side of the equation is the angle of the cosine. Okay, so And then we just have to solve it. So let's do it. Use the given measurements to solve the triangle round to the nearest tenth. Okay, so I'm going to draw out my triangle here. Let's call this A, not drawn to scale, A, B, C. Side B is 5, side A is 8, and angle C is 32.2 degrees. Okay, so I'm given a side angle side relationship, and actually the side angle side relationship is in my opinion easier than the angle side angle, or sorry, excuse me, the side 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 relationship, because I don't have to do any inverse cosines or anything like that in this example. So solve the triangle. Solve the triangle. That means I need to find angle A, I need to find angle B, and I need to find side C. Those are the three missing pieces here, right? Okay, so let's find side C first. I can't find angle A or angle B yet. I need to find side C first. So if I'm finding side C, that has to go on the left side of the equal sign, because the angle that's across from the side has to go with cosine here at the end. And these other two sides, they're interchangeable. This could be B, this could be C, this could be B, this could be C. It doesn't really matter. So let's say 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 32.2. Right? This could have been 8 squared plus 5 squared minus 2 times 8 times 5. It doesn't matter. Those are all commutative, so it doesn't really matter. So we say C squared is equivalent to, and now I'm going to put this all in my calculator here. Okay, let's do it like this. 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 32.2. Okay, that's 21.3. 21.3. And then to find C, I just square root it over to the other side. Square root. What will give me? 4.6 to the nearest 10th. 4.6. That's side C. Okay, now once I have side C, this is 4.6. I have an angle side pair across from one another. So I can do the law of sines now. Sine 32.2 over 4.6 is going to be equivalent to sine. Does it matter which side we pick? Nope. Sine, let's do sine B. Sine B over 5. Okay. And now we cross multiply and divide. We get 5. Scroll down just a here. 5 sine 32.2 divided by 4.6 is equal to sine B. So we take inverse sine of all this, of 5 sine 32.2 divided by 4.6. Okay, so we take 5 sine 32.2 divided by 4.6. We do inverse sine of that. 35.4. 35.4 degrees. And then we find the other angle, 180 minus those two. I don't have to do any trig, right? Just do 180 minus the given angle 32.2 and the 35.4 that we just saw. 112.4. Okay. And there we have it. Why did I not choose to find angle A first? Because I questioned myself at the beginning there. Once I found the side. You never want to try to do an obtuse, the possibility of being an obtuse angle with the law of sines. Okay. You never, ever, ever want to perform the law of sines and what could possibly be an obtuse angle. How do I know it could be possibly an obtuse angle? It's across from the biggest side. I never want to do the law of sines with the angle that's across from the biggest side. I think we would all agree that there's no possibility of two obtuse angles in a triangle. So I decided to go for the smaller one. Okay, I went with angle B because it doesn't, I know angle B is not possibly an obtuse angle. It's only going to give me this acute version that I want, right? And then I could just do 180 minus to find that. If I were to try to do law of sines with this information, it would give me a different answer. No way. Okay, so let's try another one. The side example. 897. Here's A, here's B, here's C. Side A is 8, side B is 9, and side C is 7. Okay, so remember when I just said you never ever want to do the law of sines with an obtuse angle? It doesn't matter for law of cosines. Okay, what's the only possibility of the obtuse angle here in this triangle? Angle B. That's the only one, because it's the only one that's across from the biggest side. Okay, so it could possibly be an obtuse angle. I'm not saying it is. I'm not saying it has to be. It's the possibility. So I'm going to perform law of cosines on that angle, so that I don't have to worry about this ambiguous case. Okay, because there's no ambiguous case with the law of cosines. So I'm going to say 9 squared is equivalent to 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of B. Okay, and at this point, I just have to get things over to the other side. This is 81, this is 49 and 64. This is 56, 56 times 2. Oops, that's right. Is 112, so minus 112 cosine B. And I'll get 81 is equal to what's 49 and 64? 113. Oh, it's so tempting. It is so tempting to try to combine those, right? It's like, please just let me make that 1. No, too bad. You got to subtract that over to the other side. 81 minus 113 gives me negative 32. It's equal to negative 112. Cosine B, we divide by negative. Just at this point do this. And then I take inverse cosine of negative 32 divided by negative 112. Find out what that is. Okay. Inverse cosine of negative 30. I don't really even need these negatives because the negative divided by negative is going to cancel. But whatever. 73.4 degrees. Okay. It wasn't obtuse, but just in case, right? So there's angle B. 73.4 degrees. Let's find angle A next. Okay. So sine A divided by 8 is equal to sine of 73.4, the new angle that we just found, divided by its opposite side, 9. So we have sine A is 8 sine 73.4, just multiplying that 8 over to the opposite side, divided by 9. So A is going to be inverse sine of all of that. Okay, so 8 sine 73.4 divided by 9, and an inverse sine of all of that. 58.4 degrees. And now angle C is going to be 180 minus 58.4 minus 73.4. 38.2. Okay, there's my answer. Not too bad. Not too tricky. Okay. All right. If a kayaker travels along an average speed of 2.5 miles per hour, how long will it take him to travel from the cave to the waterfall? From the cave to the waterfall. So finding this distance, well, this, well, I have to find the distance, and then I know I'm going to travel 2.5 miles per hour, so I got to figure out how much time it takes to get there. So let's find the distance first, right? So we know that this distance, let's call it c. C squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine 71.7. Okay. So let's put that all in. 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 71.7. 17.5. Ooh, yeah. And then I guess I'll put it over 17.46. So C is going to be the square root of that, something a little over 4. Square root of my answer gives me 4.2, we'll say. So it's 4.2 miles. And if I'm going 2.5 miles per hour, well, rate is distance over time. So 2.5 is my rate. Rate is equal to distance, 4.2 over the amount of hours, miles per hour rate. So I just switch those around. Presto changeo, 4.2 divided by 2.5. 4.2 divided by 2.5 gives me 1.68 hours. Okay. Think about that logically. I'm going 2.5 miles per hour. Obviously, it's going to take me a little bit less than 2 hours to get to 4.2 miles. 1.68 hours. All right. That's it. That's everything. Oh my gosh, it's done. We're done. I didn't even realize it. Crept up on me right there. All right. Well, it's been real. It's been fun. It's been real fun. Yeah. Oh, that wasn't the button. Figures I would screw up the stopping on the last video.